dietary pattern and its corresponding gut microbiota profile is associated with a variety of health conditions. Evidence revealed that alterations of gut microbiome by Western dietary pattern could play a role in cardiovascular disease. That is, a Western-style diet, which is typically high in fat animal protein, can promote the growth of TMA-producing bacteria in the gut. These bacteria are capable of degrading choline or carnitine into TMA, which is ultimately converted into TMAO, a metabolite linked to an elevated risk of cardiovascular disease and other health conditions. In contrast, polyphenol-rich plant-based diet increases the diversity of gut microbiota and prevent metabolic disease. In a manner analogous to the formation of TMA, a healthy dietary pattern, particularly one rich in polyphenolic compounds, can enrich the abundance of beneficial bacteria. We sought to determine particular metabolites derived from these probiotic bacteria. First, lychee polyphenols was administered to diet-induced obesity mice. We discovered that lychee polyphenols alleviated obesity caused by a high-fat diet, improved glucose tolerance and insulin sensitivity, ameliorated microbial dysbiosis, and increased the abundance of bifidobacterium. Then, we used HeapB2 cells model to select Bifidobacterium longum, one of the bifidobacterium strains that reduces lipid accumulation, to explore its anti-obesity activity in mice. We found that Bifidobacterium longum alleviated high-fat diet-induced obesity, ameliorated glucose tolerance, and marginally enhanced insulin sensitivity. Subsequently, we applied a fractionation approach followed by liquid chromatography mass spectrometry, coupled with an in vitro screening strategy to identify bioactive metabolite produced by Bifidobacterium longum. As a result, 5-methyl-5-thioadenosine was identified as an active metabolite from Bifidobacterium longum with anti-obesity potential. Using isotope labeling, we next proved that Bifidobacterium longum and other Bifidobacterium can convert methionine to MTA. Finally, MTA was delivered to diet-induced obese mice and was reported to relieve the obesity, glucose intolerance, and impaired insulin sensitivity. In addition, hepatic RNA sequencing was employed to provide a clearer understanding of the mechanism through which MTA protects against obesity and insulin resistance. Collectively, polyphenol can enrich Bifidobacterium, which converts methionine to MTA. A functional metabolite has promise in the prevention of metabolic disorders. Individually, polyphenols, Bifidobacterium, and MTA can serve as prebiotics, probiotics, or postbiotics, with each component having the potential to promote weight reduction in mice model. This finding may provide a basis for the development of innovative interventions targeting metabolic disorders by microbiome-based approaches.